Linux is by design a reasonably secure operating system, quite possibly the best that's currently out there. But that's not the same thing as perfectly secure. If you want an operating system that's open to public networks, then you'll have to learn to live with more complex security standards. The trick is to minimize your risks as much as possible. This clip will introduce you to some Linux best practices and tools for stacking the security deck in your favor as much as possible. We'll talk about keeping your system as up-to-date as possible through regular software updates, then show you how network ports work to direct server-bound traffic to the right system resources, and how you can check the status of your ports and, when necessary, secure them. First, when it comes to software updates and patches, there are only two words you'll need to know. Apply them. The Linux package management teams working to provide you with great software are also dedicated to making important security patches available as soon as possible. But if you don't download and install them, they won't do you a lot of good. So it's your responsibility to regularly update your system using the package manager. But you should also keep up with tech news sources on your own, so you hear about newly announced vulnerabilities. Historically, serious bugs have been discovered and announced at least a half a dozen times a year. On Ubuntu, you'll run apt update to make sure your local repo index is in sync, and then apt upgrade. For CentOS, it's a simple yum update. Software updates can, of course, be automated, and that'll usually ensure the job actually gets done. Although you'll want to keep an eye on things to make sure the updates didn't unexpectedly break any running processes. Now, what about network ports? Well, what is a network port? It's a number between 0 and 65,535 that by accepted convention can be interpreted by a server to direct incoming requests. Ports can permit a single network IP address to be used for multiple services. Here's a common illustration. Suppose you need your web server to support access to the pages of your website, SSH sessions for remote clients, and the maintaining of remote NTP clients. If a request is addressed to your server's IP address that's also accompanied by the port number 80, it will be directed to your root web page without TLS encryption. An identical request that comes with the port 123 will be handled by an NTP server, and port 22 would be interpreted as an attempt to open an SSH session. The proper use of network ports can turn your server into a sophisticated, multifunctioning platform. The problem is that the bad guys are just as capable of adding port numbers to their requests as anybody else. So what's to stop them from gaining access to your server's resources the same ways you would? There are, broadly speaking, three lines of defense against this kind of intrusion. The first is the way your services are configured. You could, for instance, restrict SSH login sessions to only clients with a valid key pair, blocking less secure password logins. The second approach is to close unused ports, reducing your exposure to attack. Now here I'll embarrass myself by describing how poorly I once understood this topic. Years ago, as I was just starting out in the admin world, I would often hear network security folks talking about closing network ports. I remember searching documentation and online forums, trying to find the command for closing ports, something like close port 80 or something. In fact, as I eventually discovered, you can't literally close a port, or open one either for that matter. We talk about a port as being open if there's some software running on the network-connected machine that's listening for requests to a particular port. What those admins mean by closing the port is really shutting down the listening software. With no HTTP server like Apache listening, for instance, requests to port 80 will be ignored. I'll get back to this in just a minute. But first, what about the third approach? A well-designed firewall. A firewall can be a $10,000 physical appliance from a company like Cisco or Juniper, or some open-source software like IP tables running on a regular computer. Either way, a firewall is made up of rules that are applied to every packet coming over a network. Some packets will be blocked. Perhaps they're coming from a restricted origin, or based on the associated port number, headed for a resource you want to protect. And some packets, having passed their test, will be allowed through the firewall. The firewall business is big and complicated, so I'm not going to say anything else about it here. But I will note that you can learn about Red Hat's Firewall D software in Chris Brown's Securing Linux Servers course, and about IP tables in my own Linux Network Security course. If you feel you'd rather work with NF tables or Ubuntu's uncomplicated firewall, then there's plenty of documentation available online. And Cisco firewalling? Welcome to Pluralsight, home to more than 100 Cisco and Juniper routing courses. Okay, that was a lot of talking, accompanied by very little action. My family already knows that it's not safe to get me started on this stuff. But I said I'd revisit the topic of closing ports, didn't I? So you already know what closing ports really means. But who are you going to call to figure out what software is actually running so you can shut it down? Nmap. Nmap is a powerful and complicated tool about which Pluralsight has some excellent resources, including Matt Glass's Getting Started with Nmap course. But let me give you just 2 simple examples that'll give you most of what you need right now. Running Nmap with -v for verbose and -st, which will scan using the TCP protocol, followed by localhost, will scan your own computer for open ports. This operation on one of my own computers found 2 open ports, 22 for SSH and 80 for insecure HTTP web pages. That's fine, but if, say, I didn't want to accept requests on port 80, I would simply stop and disable my web server using systemctl. Running the exact same nmap command, but against an external address like my Bootstrap IT website, will show me what's currently visible on that server from the network. This one also accepts secure HTTP requests through 443, which, coincidentally enough, we're going to talk about in the next clip. Find this useful? Why not follow the link in the description and head over to view the complete course on Pluralsight. And of course, for even more technology goodness, don't forget to subscribe to this channel.